Good morning, students. Today we are going to read about fuels in the topic of energy changes in the subject of chemistry O levels. So concentrate yourself. This is important topic. Fuels. Fossil fuels contain hydrocarbons, which are substances that contain hydrogen and carbon only. So this is the condition for hydrocarbons that contain only hydrogen and carbon. Coal, petroleum, and natural gas are examples of such fossil fuels. Complete combustion of hydrocarbons in fossil fuels results in the formation of the carbon dioxide and water. Combustion of fuels is an exothermic process because heat energy is given out to the environment. Example is here. Methane is combusted to form carbon dioxide and water. Propane, when it is burned in a plentiful amount of the oxygen, it forms carbon dioxide and water. Next topic which we are going to read is natural gas. The main constituent of natural gas is methane. Together with petroleum, natural gas is formed in the ground. Over many million years of the action of high pressure and temperature, fossil remains of marine animals and plants are converted into petroleum and natural gas. Methane burns with a blue, non-luminous flame that liberates a lot of heat energy. Hence, methane is an important source of the energy. Alternatively, methane can also be obtained from coal through a process called coal gasification, where coal is treated with oxygen and steam at very high temperature in order to break the carbon-carbon single bond to form smaller gaseous hydrocarbons. And here is the process. Carbon react with hydrogen to form methane, and carbon react with steam, water to form carbon monoxide and hydrogen gas. This is called syngas. Syngas is produced together with methane gas. Syngas can be used directly as a fuel, and it is a valuable raw material to produce useful chemicals like methanol. Exam tip for you student is methane is the main constituent of natural gas. Many pupils misunderstand that methane is a natural gas. Methane itself is not a natural gas. Natural gas contains more than 90% of methane. Actually, methane is a constituent of natural gas. Next topic which we are going to read is petroleum. Petroleum is a mixture of hydrocarbons. It is another important source of energy, especially so in transportation and as a fuel for heating. Petroleum can be separated into its components, hydrocarbons, by fractional distillation. Some of the useful fractions of the petroleum are shown in the figure below. And here is the figure. So this is the fractional distillation of the petroleum. Through the process of the fractional distillation of the petroleum, we get different useful fractions. At below 30 degrees C, we get petroleum gas, which is used for fuels for cooking. Between the temperature of 30 to 75 degrees C, we get petrol, that is also called gasoline, that is used in the as a fuel in the cars. Between the temperature of 70 to 170 degrees C, we get naphtha, which is used for feedstock for chemical industry. Between the temperature of 170 to 200 degrees C, we get paraffin, that is called kerosene, that is used in oil stoves and aircraft fuel. Between the temperature of 200 and 250 degrees C, we get diesel, that is used as a fuel in diesel engines. Between the temperature of 250 to 300 degrees C, we get lubricating oil, that is used as a lubricants, making waxes and polishes. And above temperature of 300 degrees C, we get bitumen, that is used for making roads. So these are useful fractions that can be used, that can be obtained by the fractional distillation of the petroleum, and here are their uses. This is very important question which frequently come in the paper. Exam tip for you student is the number of carbon atoms increases down the tar as density of the components increases, and boiling points also increases. In the O-level examination, uses of separate fractions are commonly questioned. Many pupils tend to write answers like petrol is used in cars. This will be marked wrong. The uses should be described as fuel in the cars or a fuel in oil lamps. Next topic which is going to be started in the lecture is hydrogen as a fuel. Hydrogen is obtained industrially from steam and methane. Here is the reaction. When steam and methane are reacted under the conditions of 10 to 50 degree atmosphere pressure, 10 to 50 atmosphere pressure and 800 to 1000 degrees C temperature, carbon monoxide and hydrogen will be obtained. Cracking of the hydrocarbons also produce large quantities of the hydrogen. Electrolysis of the water also produces hydrogen. However, this process is costly and only small quantities are formed each time. Electrolysis is an expensive method, so small quantities are formed. Combustion of the hydrogen produces water and releases heat energy. And here is the reaction. When hydrogen is burned in plentiful amount of the oxygen, water is produced and 286 kilojoule energy is released into the environment. This reaction is used in producing fuel for rocket engines. As water is a clean fuel, there is no air pollution when rockets take off to the sky. Next topic in the lecture is hydrogen oxygen fuel cell. A fuel cell is basically a battery where the anode, that is negative terminal, and the cathode, that is the positive terminal, are gases or liquids. It converts the energy stored in chemical substances to electrical energy. The reactants and the products are, however, not stored inside the cell but continuously supplied from the outside of the cell. The products are removed immediately from the cell once formed. In a hydrogen oxygen fuel cell, as shown in the figure below, the energy liberated is collected as electrical energy rather than heat energy. And here is hydrogen oxygen fuel cell. And these are the reactions which occurred at anode and cathode. So H2 plus 2aOH forms 2H2O and 2 electrons are released. At cathode, O2 plus 2H2O, 4 electrons are absorbed and 4 OH ions are formed. And this is the overall reaction. 2H2 plus O2 forms 2H2O. Here is the hydrogen oxygen cell. This is negative electrode. This is positive electrode. Oxygen gas is put in through this. Hydrogen gas is put in through this. This is platinum electrodes. And this is aqueous potassium hydroxide solution. The fuel cell is such that hydrogen is the fuel reducing agent and oxygen is the oxidizing agent. Hydrogen-oxygen fuel cells are used in spacecrafts to provide electrical energy. The water that is produced is safe for drinking and washing. So this is the method which is taken place in the space aircrafts. The main advantage of a fuel cell over an ordinary battery is that as long as the system supplying the hydrogen and the oxygen remains in the operation, power generation continues. There is therefore never any need to stop and recharge the fuel cell. This is the advantage of the hydrogen oxygen fuel cell. Now, here is a question. Methane is used as a fuel. What property is essential for this use? So answer is A. It burns exothermically. That's why this is used as a fuel. A fuel is capable of burning to produce heat energy. Hence, substances must be able to burn exothermically in order to be used as a fuel. This is the basic property of any fuel. Exam tip is, fuels need not necessarily be a gas. Carbon is a fuel, but it is a solid. Petrol is a liquid fuel. So, fuel can be in any form. It can be gas, solid or liquid. And other question is here, electrical energy is produced by a simple cell as a result of. So, in a simple cell, the transfer of the electrons from more reactive to less reactive elements take place. Answer is D. Flow of the electrons from one reactive metal terminal to another results in the formation of the electric current. Exam tip is, covalent compounds do not conduct electricity. Only metals and ionic compounds do so in molten or aqueous state. Another question is here. The diagram shows the fractional distillation of the petroleum. Here is the figure. Which statement about fractions X and Y are correct? X is above, Y is below. So the answer is B. X burns more easily than Y because that is above, and X has a higher boiling point than Y. Answer is no, because Y will have higher boiling point. So B option is right. X has fewer carbon atoms than Y, hence is less dense than Y. It burns more readily than Y and has a lower boiling point than Y. The greater number of the carbon atoms, the harder it is to break the intermolecular forces between the molecules of the compound. Hence, the boiling point of the compound is higher. A fuel is a substance which can be used to produce energy. Most fuels liberate energy when burns in air or oxygen. These fuels are compounds of carbon and hydrogen, the elements hydrogen and carbon and the carbon monoxide. Fuels can be classified as solid fuels, liquid fuels, and gaseous fuels. And first, we are going to read solid fuels. The most important solid fuel is a coal. Coal is a fossil fuel composed largely of carbon. A typical coal sample contains 80% carbon, 6% hydrogen, 6% nitrogen, 5% oxygen, and 3% ash. The coal was formed by the action of the heat and pressure on plants over millions of the years. Anthracite is a form of the coal consisting of larger percentage of the carbon resulting from more complete decompositions of the plants. When coal is burnt in excess air, carbon dioxide gas is produced. However, other products formed including water vapors and sulfur dioxide. The sulfur dioxide produced causes pollution problems, and for this reason, smokeless fuel is preferred to coal. Destructive distillation of the coal. When coal is heated to about 1000 degrees C in the absence of the air, it does not burn. It splits up and forms four products. And the products are coal gas, ammonia solution, coal tar, and coke or smokeless fuel. Here is the figure that is showing destructive distillation of the coal. Powdered coal will be burnt, will be heated up. This is the setup, and coal gas will be collected over here above the water. The coal gas produced is used for household gas supply, but it has now been replaced by natural gas. Coal gas consists chiefly of hydrogen with smaller amounts of methane and carbon monoxide. The ammonia produced collects in the water. It can be used to make fertilizers. Coal tar is a complicated mixture of the hydrocarbons and closely related compounds. It can be separated by fractional distillation into valuable chemicals, for example, benzene and toluene. Next topic in the lecture is liquid fuels. Liquid fuels include petrol and paraffin. They are often obtained from crude oil. Petrol is a mixture of alkanes including octane. Compounds including tetraethyl lead, formula is here, are added to the petrol to improve the combustion properties. Other liquid fuels include the family of the alcohols, including methanol and ethanol. Next topic in the lecture is gaseous fuels. The most important gaseous fuel is methane. It is found as natural gas, either alone or associated with crude oil. Natural gas and oil were formed by the action of the heat and pressure on the remains of small sea creatures. They are trapped below ground by layers of the rock that do not allow the natural gas to escape. Other gaseous fuels include water gas and producer gas. Producer gas is formed when air is passed over red hot coke, that is carbon. And here is the reaction. 2C plus O2 plus N2 forms 2CO plus N2. This reaction is exothermic and the producer gas yielded is a mixture of carbon monoxide and nitrogen. Here is the product. Producer gas is not a good fuel because it contains a large proportion of the nitrogen which does not burn. It is, however, cheap to produce. So, it is cheap to produce but not considered as a good fuel. And this is the natural process which occurred in making of the gas and oil. Impermeable rock, permeable rock, impermeable rock. So this is the natural process, formation of the oil and natural gas. Water is produced when steam is passed over white hot coke. So this is the process. This is an endothermic and the coke has to be reheated if the reaction is to continue. Water gas is a mixture of the hydrogen and carbon monoxide. This is the product which is called water gas. It is a good gaseous fuel because carbon monoxide and hydrogen burn. Next topic is, which is the best fuel? This is a very common question which frequently come in the paper of 1 or 2 marks. Which fuel is the best to use? There are a number of the factors that determine which fuel is the best for particular purpose. And factors are here. Number 1, price. Number 2, ease of the storage. Number 3, energy value of the fuel. Number 4, ease of the transport. Number 5, ease of the ignition. Number 6, percentage of the impurities. Number 7, pollution products. So, this was the topic, students. This is very important topic as far as chemistry paper is concerned. So, read this lecture again very carefully and make your notes. Thank you so much, students.